Very good afternoon to all of you, those who are present over here. My name is Satish Yadav, and today we'll try to see one of the important topic of a combinatorics, and that is called as what? That is called as a permutation. So most of the time the students are having a doubt about this permutation, okay, and sometimes they are getting confused, sir, which type of questions we have to solve with the help of a permutation, or which type of questions we have to solve with the permutations with repetitions. So this session is dedicated to that particular topic, how we can solve the permutations question. See, basically I'm coming with the whole series. Yesterday I taught one particular topic, that is product rule and sum rule. All are independent topic, okay, and today we'll go and we'll try to see the basic concept of a permutations, and a little bit related concept related to that, and that is nothing but what? That is nothing but permutations with repetition. Okay, so we'll go and we'll try to understand about the permutation, but before understanding about the permutation, there are certain things that we have to understand, and that is related to what? And that is related to which is nothing but called as a product rule. So we'll see a little bit concept of a product rule, and then I will tell you basically what is the concept of a permutation, and then I will tell you what is the concept of a you can say the combination. So there is one concept that everybody has to understand, and that is nothing but permutation. So as I told you, this is the whole session that is related to that, okay, and welcome to all on this particular platform, Gradeup. Okay, so let's go and let's talk about that particular thing, okay. Okay, so this is me, and people also call me Baba, and those people who are knowing about me and those people who don't know about me, I have taught more than 1 lakh of students. Yes, you heard it right, and I'm having more than 8 years of experience and many times get qualified, and I'm also a researcher, you can say that. And here we are having this particular batch. So those people who wants to join it, those people can join this particular batch, and we are having the structures faculty, and we are having the structures course that you people can get it. See, getting a structure course is very, very important. You know why getting a structure course is very important? Because you don't have to, okay, very good afternoon, Raj. Okay, you don't have to go here and there and to collect the materials. No, it's nothing like that. The structure schedule is very, very important, because you don't have to dedicate your time of collecting the material. See, you know, the problem is whenever we prepare any particular examination, whether it's, you can say, the GATE, ISRO, BARC, or even the UPSC, okay, so if you'll prepare any particular examination, the first thing that students do is basically to see the syllabus. After seeing the syllabus, they actually collect the material, and sometimes collecting the material is such a tedious job. You know, you have to go there and you have to collect that faculty material, and that faculty is famous for this particular subject, that faculty is famous for this particular subject. So now you don't have to do anything. All the things are available right now on this particular platform. So in order to take the admissions, you can contact on this particular number, and what is that? That is nothing but this. So if you will be contacting on this particular number, they will be assisting you to take the admission into that. Okay, so this is all about the Gradeup, because all the faculties, all the famous faculties with respect to the subjects are available on the Gradeup. Okay, so we'll talk about the permutation, as I have promised that I will be teaching you the permutation. But let me tell you, yes, Rajkumar, I will be teaching on the super batch also. Okay, don't worry about it, I will be taking that subject. First, let me start with the discrete mathematics, and once I'll complete it, and then I will also take it, okay, based on the requirement and based on the availabilities. Okay, so we will be talking about the permutations, and instead of talking about this permutation, let me tell you about the product rule. So the first thing that you have to understand is product rule. See, what is the product rule? Product rule is the basic concept of combinatorics. It will teach you where to do the multiplication. Once you can understand where to do the multiplication, then you can also understand which is called as a permutation. So instead of seeing this particular definition, first we'll try to understand what is a product rule. Product rule is basically saying when the things are happening simultaneously, then you can multiply. For example, suppose if I will have 10 students, and if I want to arrange into 3 different places, So what you will be doing, at the first place 10 ways, first student is there, second place 9 ways. So according to the multiplication, what you will be doing, let's see one example and then I'll come to this particular definition. Okay, let's consider this is a one particular set we are having, and then we have to do the 2 permutation of S. Right now don't see this word as a permutation. Right now what we will be seeing, let's consider we are having a 3 elements over here. So I will show you the product rule, the permutation, combination. Let me give you the visualization of that. Let's consider we are having a one particular set. Now if I want to take 2 elements, if I want to arrange 2 elements out of this, then what you will be getting, you will be having a 2 places. Okay, let me write over here the first thing that we have to understand with respect to the product rule. So here we will be having what? Here we will be having the product rule. Now what is that product rule? So let's consider we are having a one particular set, then out of that we are having a 3 elements into that. Now if we want to arrange up to 2 places, then how many ways you can do it? So at the first place, how many ways you can take any element and put it over here? Either I will take A, or I will take B, or I will take C. So here you will be having a 3 ways, and then once you will put any element on the first place, then what will happen at the second place? How many ways you can do it? Then you can do it in how many ways? That is called as what? That is called as a 6 ways. This is called as a product rule. Why? Because the things are happening simultaneously. So how many ways you can arrange 2 letters if you will be having a 2 places? So you will take one element out and you will put it. How many ways you can do it? You can do it 3 ways, and then after that again you will take one element and put it over here. Then how many ways you can do it? 2 ways. So 3 into 2, that is nothing but 6 ways. See, there is no permutation over here. There is no permutation over here. Now this is just a product rule. So you can skip permutation, but you can also solve the questions with the product rule. Those people who hates this word as a permutation, you can solve with the help of a product rule. Now let me give you the visualization of this, how it is happening. So at the first place, any letter you can write, how many ways? 3 different ways. Either you will write A, or you will write B, or you will write C. Once you will write A, then you can write either B, or you can write either C. Once you will write B, you can write either A, or you can write either C. Once you will write C, then you can write A, or you can write B. See, this is 6 ways. This is the total visualization of that particular 6 ways. Now there is one thing that you have to understand, and see, here you can see that at the first place you can write something in 3 different ways. This is 1 way, this is 2 way, this is the 3rd way. Now if you will fix A, then how many ways you can write something else? This is 2 different way. So as you can see, this is the visualization of the product rule. If you will write something over here, suppose if you will fix B, then again for that you will have 2 different ways to write it. Again if you will put C, then again you will how many ways you can write it? You can write in 2 ways. So that is nothing but what? That is the, you can say that, linear arrangement of an element. So along with the product rule, linear arrangement, if this word comes, product rule and linear arrangement, then you can use what? You can use the permutation. So actually permutation is nothing but the extension of a product rule with the linear arrangement. Now if you want to understand, suppose if I will be having what? If I will be having, so let's try to go first with the product rule and then sum rule. Now with the permutation. Suppose if you will be having n objects. Suppose if you will be having the n objects, and if you want to arrange at r places, according to the product rule, what you will be doing, let's try to understand. According to the product rule, what you will be doing, so at this particular place, how many ways you can write anything? So you can write in how many ways? N ways. At the second way, how many ways you can write it? You can write in n minus 1 ways. Yes or no? So how many ways you can write it? N minus 1 ways. And then second one, which is nothing but how many ways you can write it? You can write in n minus 2. And at the rth places, how many ways you can write it? You can write in n minus r plus 1. So basically this is your product rule only. So if you will be having the n objects, if you want to arrange at r places, according to the product rule, it is saying that at the first places, see, you can match this thing. Suppose if you will be having a 3 elements, if you want to arrange this 3 element at 2 places, how many ways you can do it? First one 3 ways, second one 2 ways. Now try to relate it. If you will be having the n objects, and if you want to arrange at r places, then the first one you can write in n ways, second one n minus 1 ways. Now try to understand this particular concept. And what is that particular concept? Let's try to go and let's try to understand over here. Okay, So suppose if I will be writing this thing n ways, now what will be happening, n into, and then you will be getting n minus 1, you will be getting n minus 2, and then you will be getting n minus 3 dot dot dot, you will be getting n minus r plus 1. Now there is one thing, see, initially the product rule came, and then there is one mathematician consider. That mathematician has said there are 5 elements. 5 elements you have to arrange at 3 places. So 5 into 4 into 3. 7 elements you have to arrange at 4 places. 7, 6, 5, 4. Now this faculty or this mathematician got frustrated. Every time I have given a product rule and every time the persons are asking, keep on asking this, that, this, that. So that faculty understood, that faculty thought that let's try to give a general version of that. And what's that general version? So this is a general version. Suppose if you'll be having the n object and you have to arrange at r places, so n into n minus 1, n minus 2. Now what you will do, n into dot dot dot, here you will be having n minus r plus 1. Now multiply with n minus r factorial and then n minus r factorial. So what you will be getting? You will be getting is basically n factorial and then n minus r factorial. This is basic concept of what? They have given this name as a permutation. So basically this is your permutation. Extension of a product rule is called as what? Extension of product rule is called as a permutation. So here this is your permutation. An object at r places, product rule, along with that extension, we can say that this is nothing but called as a permutation. So instead of writing every time product rule, what we can do is basically we can generalize this thing, and what is that generalized thing is nothing but an object at r places is called as what? Is called as your permutation. Now let's see that definition. What is that definition? A permutation of a set of distinct, or you can say that it is linear arrangement. Linear arrangement, as I have told you, it is an extension of a product rule, that you have to understand. If you want to use permutation, no problem. If you want to use, instead of that, you can use a product rule also, no problem at all. Okay, so what the thing that I have proved over here is basically nothing but these things only. Okay, so here what we will be getting is basically, is basically this particular thing, and that is nothing but what? N into n minus 1. This is basically called as what? This is basically the definition of what? This is basically the definition of a permutation that we are having over here. Okay, let's consider there is one question. How many ways are there to select the first prize winner? Okay, the first prize winner and second prize winner and then third prize winner. If you want to use, you can use the permutation or you can use the product rule. So basically there are 3 places, 1, 2 and then 3 places. Now first I will try to use the product rule. So what is a product rule? In product rule you should have the visualization. If you are lagging the visualization, you can use the permutation over there. So at the first places, how many ways I can write it? That is nothing but 100 ways. And then at the second places, if you fix that person, then here you will be writing in 99 ways and here you will be writing in 98 ways. Now this is a product rule. Now if you want to use a permutation, then there are hundreds of objects, and that hundreds of objects you have to arrange at 3 places. So either you can use the product rule or you can use the permutation. It is totally your wish. It is totally your wish in order to understand that particular thing. So either you can use the product rule or you can also use the, which is nothing but called as what? You can use the permutation. I hope you are getting. Okay, so reply. I can see all of you replying. Okay, so whatever you people will reply, we can, I can teach in some different manner also. Okay, I can teach that thing with some different manner also. Okay, how many permutation of the letters contains the string ABC? Now see here. This should be as a one block. This should be as a one block. Now what will happen if this is going to be as a one particular block, then this you can count as a 1. Now this is 2, this is 3, this is 4, this is 5, this is 6. No, so the total answer you will be getting is basically the 6 factorial, where the string ABC contains as a what? 1. Actually, you might be thinking, sir, where is the object and where is the places? When your object and places both are same, you will be getting the n factorial. That is the concept of a permutation. So how many elements we are having? So this is 1 place, this is 2nd place, this is 3rd place, 4th place, 5th place and 6th place. So suppose if you will be doing something like that, so what they are saying, what their condition demands, their condition demands such that ABC should be in a one particular block. Then only you can solve this particular question. Okay, let's see the next one over here. Permutations with repetitions. Permutations with repetitions. Suppose if you will have the n objects. Suppose if you will have the n objects and you have to arrange at r places such that for every place you can repeat n times. Such that here you can write something as a n times. Suppose here if you also write something as a n times, you can also write something as a n times. So at the rth places, what you will be getting? You will be getting n raised to r. Now try to understand this particular thing. This is the same concept as how many ways we can generate two particular, or how many ways we can generate total number of a code if I will be having a two places. So suppose if you will be having a two places, then what will happen here? You can write something either 0 or 1. You can repeat it. So you can write something in two ways. Here also you can write 0 or 1. You can write something in terms of two places, so that you will be getting 2 raised to 2. Now what will happen if you will be having a three places? So but here what you will be getting, the possibility says that in this way you can write something in two ways, you can write something in two ways, you can write something in two ways, and then 2 raised to 3. So basically this 2 is defining the possibility, while this 3 is defining the places. So here n is basically defining the possibilities and r is defining the places. So you can also write something like that, such that possibility raised to places. So this is where the repetitions are allowed. Where the repetitions are allowed in this way, in this manner, you can go and you can try to understand, and that is the basic concept of what? That is the basic concept of a permutations with repetitions. So possibility raised to places. So any question if it comes, then you can solve with the help of this particular concept, and that is nothing but permutation. Let's see one particular concept that is related to that. Let's consider there are 25 true or false questions. So first of all, try to write down the data. What is the data that they have given? See, always try to decode the questions. So they have given 25 questions. So out of these 25 questions, they have given 25 questions, and this is basically true or false type of questions on examinations. Then how many different ways student can do the examination if he or she can also choose to leave the answers blank? Actually, they are giving the 3 types of possibilities. And what is that possibility? Such that first one, either you can write true, or you can write false, or you can skip it, okay? Oh, they are saying that you can choose to leave the answers blank, or you can skip it. Now what will happen? Let's consider this is one question. So how many possibilities this question will have? This question is having 3 possibility. Either you can mark true, or you can also mark false, or you can skip it. Okay, you can skip it. This is one first particular question that you will be having. Now with respect to the second question also, again you will be having how many possibilities? 3 ways you can do it. 3 possibilities you will be getting. And then the third question, in this manner, if you will go and if you will try to understand, so over here this is the 25th question that you will be having. Again this one is also having how many possibility? This one is also having a 3 possibilities. Now if you will try to understand over here, so the first question is having 3 possibility. So how many ways you can do it? Something like that over here. This is 3, and then this is 3, and then this is 3, and likewise at the 25 places. So over here at the 25 places. So what I told you, possibility raised to what? 3 into 3, 3 into 3, possibility raised to places. So what you will be getting the total answer? You will be getting 3 raised to 25. So this is your answer, 3 raised to 25. 3 is basically defining as what? 3 is basically defining as what? 3 is defining? 3 is defining the possibility. What 25 is defining? 25 is defining what? 25 is defining which is called as the places. So possibility raised to places, number of ways raised to places, is basically your permutations with repetitions. So in this manner we can go and we can try to understand all the questions that is related to this particular concepts. I hope you got it. Okay, let's go and let's try to understand the other type of questions that is also very important into the gate. Let's consider how many different strings can be made by reordering the letters of the word all. Instead of writing all, let me try to write down what will happen if, or instead of writing all, okay, first I will be giving you how many ways you can arrange this. Okay, all, where L1 and L2 are different. One possibility is either you can write something like this, or one possibility you can write L2 and L1 are different. So other possibility L1 A and then L2 and then L2 A and then L1. Now what will happen if you will be writing L1 L2 A? Here you will be writing L2 L1A. This is the visualization that you people are having when L1 and L2 are different. Okay, so actually the original question contains how many ways we can differentiate all. Now what will happen if I will take this L and L are different, then what will happen? This is the total possibility. But so this is the cases where L1 and L2 are different. Okay, where both L1 and L2 are different. Now what will happen if your L1 and L2 are same? Okay, now if your L1 and L2 are same, these two combinedly you can write something in terms of like this. Now what will happen if something is like this? What about this? So here L and then A and then L. Now what will happen if I will be going with the third possibility? So this one is defining as what? This one is defining, which is nothing but L, L and then A. Now try to understand. See, where L1 and L2 are different, here L1 and L2 are different, but here L1 and L1 same. But if you will go and if you will try to understand the original question, what's that original question? Original question contains how many ways we can arrange the letter all. So can we define something with respect to something like that? Can we define something like that? See, how many ways we can do this whole thing? That you will be getting what? That you will be getting in 3 factorial ways. Yes or no? That the whole thing you will be getting in 3 factorial ways. But this is the reality when L1 and L2 are different. What about when they are same? So these two will be what? This two, the whole thing will become this. This two will become this. This two will become this. So what you have to do? So basically 3 factorial divided by 2. So this is the similarities that you will be getting. Okay, so if your similarity, if you will be dividing, then you will be getting what? You will be getting the answer. So can we generalize? See, this is basically the proof of the next theorem that we will be going and will be trying to understand. So 3 factorial divided by 2. Now what will happen if I will go and if I will try to understand something like that? So let's consider the number of a different permutation of n objects. The example that I have already given, where there are n1 is of one type, okay, where n1 is of one type of type 1 and n2 is of type 2 and like nk is of another type, okay, of type k. Now what will happen if you try to understand? So the total ways we can write is basically n factorial and n factorial. See, n factorial is there and out of that we have to divide with n1 factorial, n2 factorial. See, this n1 is of type 1, n2 is of type 2. So if you want to understand this particular thing, you can also understand like that, where 3 factorial divided by 2 factorial. Okay, where this one is of type 1, L and L both are same. So in this way you can correlate it and you can easily understand the whole particular concept, how we can go and how we can try to understand the whole particular thing. So how many different strings can be made by reordering the words later? So this is the visualization, what we are learning and what we are not getting it. Okay, and this is of type 1. In this manner we can go and we can try to understand the whole particular concepts. Let's see one question. So how many ways the different strings can be made by reordering the letter of the word success? So how many total letters or total elements you will be getting? So the total elements that you will be having, first try count it. Total elements, this is 1, 2, 3, 4, 5, 6, 7. So you will be getting 7. Of S will be of how many ways? This is 1, this is 2, this is 3. So S is of type 1. Okay, and that how many repetitions? 3 repetitions. And C will be of type 2. So what you will be getting? So the total ways you will be getting over here, the total ways you will be getting is basically 7 factorial and then divided by this S will be of 3 factorial and then this c will be of 2 factorial, and with respect to u and with respect to e, so here you will be getting 1 factorial and then 1 factorial. So this is the total answer that you will be getting. So if you want to understand this type of questions, okay, if you want to understand this type of questions, you can easily learn the way I taught just 2 slides back. So that gives you the visualization why we are doing it. If any person wants to understand why we are dividing by 3 factorial, okay, why we are dividing by 3 factorial, no, Raj, this 2 c and c are, there is a repetition, so we have to divide by 2 factorial. If anyone wants to understand why we are dividing by this, so let me give you the visualization of that with the help of this. We are dividing because when L1 and L2 are different, that will be something different, but what will happen if they will become the same? So every time we have to divide it, and that's how we'll be getting what? That's how we'll be getting, which is nothing but division by 2 factorial. In this way you can understand the whole concept that is related to. Okay, staircase problem. This is for me, okay. Let's consider there is one question, something like that. Okay, there is a staircase problem. Okay, this is one question. See, you can consider this thing as what? You can consider this thing as there is one, you can say that there is one coordinate system. Let's consider this is x as 6, okay, and this is your y axis. Let me give the numbers also. So this is 1, this is 2, this is 3, 4, 5, 6 and 7, and this is 1, this is 2, this is 3, this is 4. Okay, now there is one robot that is situated over here. Let's consider there is one robot that is situated over here. So let's consider, so there is one robot that is situated at 2, 1. Let's consider there is one robot that is situated over here, and that robot wants to go from a coordinate 2, 1 to coordinate 7, 4. Okay, that person wants to, or that robot wants to go from a coordinate 2, 1 to coordinate 7, 4. Now there is one condition. You can consider this as game. There is one condition. The condition is that person can only take 2 possibilities. Either that person can go to right, or that person can go to up, or that robot can go to right, or that robot can go to up. Now let's consider this particular situation. See what is happening. So how many ways or how many possibilities will be there such that that person will be going? One possibility is something, okay, one possibility is something that robot is starting, see this is up, right, up, up, and then right, and this is one particular possibility. Second type of possibility that robot can take is basically right, and then up, and up. So if you will try to understand, you might be getting confused how we can solve this particular question. But if you will try to focus over here, how many rights and how many ups you are getting. So if you will try to understand, one particular possibility is something like that. That robot can take 5 rights and 3 ups. Now if you arrange this particular letters, okay, if you can arrange this particular letter, that will be the total possibilities. See, this is one possibility which is nothing but up, this is right, this is up, this is right, sorry, this is also up, this is right, this is right, this is right, this is right. So in this manner, so the number of ways to arrange this letter is basically defining how many ways the robot can go from 2, 1 to 7, 4. So how many ways we can do it? We have already seen it, right? So there is a repetition. We can say that repeated value over here. So how many R will be there? 5. And how many U will be there? 3. So if you will try to understand this particular question, then total is how much? 8. So what you will be getting? You will be getting 8 factorial and then divided by 5 factorial into 3 factorial. Okay, just now we have already seen it. So in this manner we can solve all the questions that is related to this particular thing. So 8 factorial divided by 5 factorial into 3 factorial. This is a total number of ways that robot can go from 2, 1 to 7, 4. Now I converted this problem to that permutations with repetitions problem where the repeated elements are there. And why we are dividing, I have already given the total number of possibilities. I have already gave you the visualization. Based on that visualization, you can easily understand that particular thing. Okay. So in this manner, you can also understand how we can solve this type of question. So I just wanted to show you is basically how the whole situations are working when there is a permutations with repetitions. So in this manner, so if anybody wants to understand the permutation, the first thing that you have to do is basically product rule. After product rule, you can understand the permutation, and then I have given the visualization of permutations with repetitions. Okay, so in this manner we can do each and everything. Okay, so thank you for listening this class. Okay, so we'll be stopping here only. So right now I'm taking the small section, okay, so that you will be getting comfortable with the help of Combinatorics. But if you want to understand more about this, which is nothing but the whole thing, so here we are having this experts faculty, those who will be teaching you into the batches. Okay, and we are having the different course structures. And March 13 we will be starting the weekend batch, and for a streamlined situations I will be giving you the whole discrete mathematics in a streamlined manner. So you will be getting the sequential discrete mathematics problems over here, and that is nothing but with respect to this particular. We have already started one particular batch, so you know the difference interval we will be starting, you know, different types of batches. Very good afternoon, Nishu. Okay, and those people who wants to take the admission, they can also, you know, call on this particular number. I'm sure they will be assisting you. Okay. Okay, these all the faculties, those will be having the possibilities, and they will be taking your lectures. Okay, so thank you so much, guys. Okay, so every day on a Gradeup free app, you can also follow me on a Gradeup free app, and you can like this session. Okay, and those people who are scared of permutation, you can share this session with those particular students. So every day on free app, Gradeup app, I will be teaching on app. Okay, at around 12 p.m. except Thursday, and on YouTube at around 2 p.m. Okay, this is my schedule. Except Thursday, I will be available on each and every particular day. Okay, so for free app, you download the Gradeup app, and if you want to understand the concepts, the very basic concepts, or suppose if you want to learn about any particular concept, suppose sometimes the students are saying, sir, I cannot understand the bell number. What will be the toughest concept that you people were having? Just comment that particular concept, okay, on the YouTube channel, and I will come up with the solution of that. I will come up with the concept of that. Okay, so in this manner we can do the whole thing. Okay. Okay, thank you so much, guys. You can like this session, and you can also share this session with all of your friends, those people who are scared of permutations. Thank you so much for watching this video, and I hope that you have enjoyed. Thank you. Bye bye. Have a great day ahead.